So hello everyone, welcome back again. So in the year study, we uploaded a lecture on what is the binary compositions and some few examples. So today we will see some few more examples and two more properties. Not two more properties, two more definitions about binary compositions. So let's see some. First of all, let's discuss about the definitions. Okay. Uh, you already encountered this type of definitions maybe in your class 12. I don't exactly remember the things. Okay, so start it. So first one is your commutativity. Okay, commutative. Okay, or commutativity, whatever the thing is. So what is commutative in binary compositions? So if you have ever seen that A compose B or your B compose A will be equal for all A comma B within the set A, then we will say that A comma B, I mean this binary composition is commutative. What does it mean? It means that if you do A comma B, I mean A compose B or B compose A, it will be same thing. Like for the plus sign, if you do 1 plus 2 or if you do 2 plus 1, both will give the same answer, right? So this type of operations or this type of binary composition, we say that it is commutative. Second one is your associativity. Okay, so what does it means? Associative means if you do A compose with B compose C, it means if you do first B compose C and then compose with A, or if you do A compose B first and then compose C for all A, B, C in A, then if this happens, then we say that this composition or this binary composition is associative. Okay, so let's give some examples of this thing. Example. Okay, first example is very much obvious, like for the addition symbol. Okay, for the addition symbol on the set, addition on any set. Okay, on any set, like it is real number, it is in your integer set, if it is in your natural number, if it is in your complex number, or it is in your matrix. Now you have to see the notations. Okay, like the notations for the matrix we use M. Okay, and if it is of order n cross n, we'll write as n cross n, and under here this is R. It means this is a set of matrix of n cross n. This is a set of matrices of n cross n whose all the indices are from real number. Okay, or you can say if you consider this n cross n matrix over the field complex number, actually this is called field. We'll do it very later thing, but it means that if it is a set of matrices of order n cross n whose all indices are from complex number, so in these sets this plus sign is always commute, पूरा लिख देता हूँ, commutative and associative. It's very obvious. I just already told you that if you do 1 plus 2 or 2 plus 1, it will give you same. Or if you do like A plus B for the matrices, if you do A plus B or B plus A, it will also give you the same answer because it is actually plus. Okay. For the second thing, if you do, let's suppose if you do minus, or if you're talking about minus symbol, it is not commutative in any set. Okay, if you're from a real number, for say in whatever the thing is, it is not commutative. Because why it is not commutative? Not commutative, not associative. Why? Because if you do 1 minus 2 and 2 minus 1, both will not give you the same answer, right? Or also why not associative? Because if you do 1 minus, let's suppose 2 minus 3, it will not exactly equal to 1 minus 2 minus of 3. That is the thing now. If we take composition as minus symbol, so obviously it is not associative, because if you do 1 minus 2 minus 3, it is not exactly 1 minus 2 minus 3, right? So fine, these are some examples. Let's give you some another beautiful example, that is regarding set theory. Do you know power set? What is power set? That is, power set is all possible subsets of a non-empty set, okay, or of any set, okay, all possible subset of a set. So let's start, like S is a set, okay, S is a set, and try to practice, okay, by writing maths, because if you are a B.Sc student, or if you come into B.Sc without knowing anything, someone is telling you that you should go into the B.Sc Mathematics. There is lots of scope, yes, there is lots of scope, but after not after B.Sc, after M.Sc, okay. So you should take mathematics. But if you are in some imaginations that I have to do lots of calculations, if you're wrong, okay, here we will just do theoretical things, theoretical analytical things, okay. So you have to do you have to write a lot, okay, because if you explain something, so sometimes you have to feel that uh, am I mathematics student or English literature student, so you don't understand that, okay, because there is lots of theories you have to prove, okay. So practice practice these things from the beginning. So AC is a set, and power set is a power set, okay. Because I am not writing, because I don't need it right now, okay, and you also don't need it from these things. But whenever you're encountering theory or something more than that, so you have to write or explain it by writing it, okay. So power set is a PP of S. So now if we considering A compose B, you know that we write set as capital letter as A union B, okay, this is one. Another one is A intersection B. Another one is A symmetric difference of B. You know that what is symmetric difference? What is symmetric difference? Symmetric difference is, this is called symmetric difference. This is your A minus B union B minus. Now what is A minus B? A minus B means set of all elements of A which is not in B. Okay, set of all elements of A which is not in B, and B minus A means set of all elements of B which is not in A. So I think I hope that you know this. So A compose B, this is A compose B. Now if you check that it is, this composition is commutative or not under union, intersection, and similar difference, so what you will do? Just you have to check that B compose A. Okay, B compose A, for the union thing is B union A, for the intersection is B intersection A, and for the symmetric difference is B symmetric difference A. Now you tell me there is any difference between A union B and B union A? I think no, because if just union it, right? So you have to collect the all the elements, all possible elements of A and B. So there is no difference between A union B and B union A. There is no difference between A intersection B and B intersection A. And similarly, there is no difference between A symmetric B and B symmetric A. Both are same. Because if you see the graph, if you see the visual, like this is A and this is B. Oh, sorry. Sorry. We have to take the intersection part also. This is A, and let's suppose this is B. Oh, this is A, this is B. So this is your intersection portion. So A intersection B and B intersection A gives the same answer. Okay. This red portion and this red portion is your symmetric difference, A minus B union B minus A. So this A minus B union B minus A or B minus A union A minus B, both are same thing. So this will give also same answer. And what is the union? Whole thing. If you take whole thing, this is your union. So there is no difference. So it is commutative. Okay. Wait. So it is, say, we say that A composition B equals to B composition A for all AB in the set S. Hence, this composition is commutative. Okay, and check for associative. It is also associative. So this is your task. Check for associativity. Okay. Okay. So check for associativity. So similarly, if you can check for associativity. Okay, so let's jump into the questions. Okay, some important or very good questions. Okay, for example, if you take any questions from, yeah, I follow the books. Okay, obviously, like I don't make myself a questions, right? Okay, so yeah, so let us define, like, composition is defined. Your battery is running low. Wait a second. So composition is defined on R, and definition is A compose B equals to half of, I guess, not half of, it's only AB. Okay, this is half of, I mean only mod of AB. A comma B belongs to R. And what is the question? It is commutative or not. So before jumping to the direct commutativity and associativity, you have to first check this composition. I mean, this operation is actually forms a binary composition or not. So it's very obvious, since it is a real number and there is no undefined things over there. So for any AB you take, so mod of AB is also in real number. Okay, it will not be into the complex field, right, or something else. So it forms a binary composition. So now answer is, first thing, commutativity. So for commutativity, what you have to do is you have to take A compose B. So A compose B is your mod of AB. So if I write it as BA, okay, then I can write it as B compose A. चलो ये अगर सही नहीं लगता तो इस तरह से करते, A compose B equals to AB. Now calculate B compose A. So B, what will be B compose? When A is in first place, so it is AB. So when B is in first place, so it will be your BA. So now you tell me, is there any difference between mod of AB and mod of BA? No. So obviously A compose B equals to B compose A for all AB in R. So yeah, it is in, I mean, it is commutative. Yep. So second one is associativity. So you have to just take three elements from real number. So first calculate A compose B compose C. Okay, so what is your A compose B? A compose B is your, what happened? Okay, A compose B is your mod of AB compose of C. So it means mod of AB into C, then whole mod. Very carefully. When A compose B, so A and B multiplied and then take whole mod. So now considering it, so let's break it down first. Now considering this is your A. So what will be your A compose C? What will be your A compose C? That is mod of AC. Now what is your A? Your A is mod of AB. So it will be your mod of AB into C. Okay, that's very easy. Now if you take it, okay, you take it C, mod of AB into C, you can rewrite this as, here we get A compose B as mod of AB into C. You can rewrite as mod A into mod B into mod C and whole mod, not mod C. Okay, okay, you can write it as like this. So now tell me, if I give mod A and mod B over there, okay, so let's break it down for you very quickly. B compose A, okay. So what do you do? Yeah, not B compose A. I'm confusing. I'm thinking that you will not understand. A compose B compose C, ये हमने कर लिया था. A compose B compose C कर लिया था. I have to do this like thing. A compose B compose C means mod of BC, and then it means A into BC. Okay. Now tell me, is this equal or not? So I can write it as A mod B mod C whole mod. Okay. Write it. Okay, G. So what will I can write it as ABC. That's I want to tell you from the very beginning, but मेरे को लग रहा है कि आपको समझ नहीं आएगा. That's the thing. Because whatever the value of A is, whatever the value of A, B, and C is, whatever, ultimately at the end there is a final mod which exactly give you the positive answer. So what will be in the inside part of this main mod? It is negative, positive, doesn't matter. Ultimately there is a final mod, okay, which give you a positive answer. So whatever the sign inside is doesn't matter. Just you have to just take the you have to just take product, and what will be the sign is, as at the very ending portion there is a mod, so it will give you a positive answer. So I can rewrite this as mod of ABC and mod of ABC, and since this mod of ABC is equal, so you can write this as A compose B compose C is equal to A compose B of C. So for all A, B, C in A, I mean it's A, whatever the thing is in real number, okay, in real number. So yes, it is both commutative and associative. There is a question for you, okay, easy question, uh, very easy question, composition on, this is composition on Z cross Z. Now set is your Z cross Z, okay, defined by, how it is defined, that A comma B compose C comma D is equal A minus C B minus D, okay, where this AB and this CD both belong to Z cross Z, okay. I mean, what we will do from the very beginning, we're just crossing A cross A. But if your set is Z cross Z, I mean, if your set A is Z cross Z, then we have to take Z cross Z cross Z cross Z. So mapping is your binary composition is if this to Z cross Z. Am I very, I mean, fast or whatever the thing is? Should I mean, am I look like university professor? कि मैं बहुत fast बता रहा हूँ, ये सब क्या है? Let me clear you very, I mean, don't confuse it. Like here we did just from one set. We just played the game from the one set. Okay. Here there is a Cartesian product Z cross Z, and here you have to find it is commutative or not. So what I mean, which you can do is just A comma B compose C comma D, and for the commutativity you check C comma D compose A comma B. Okay, if this portion is equal, then you will say they're equal. Obviously there is a minus and it is not commutative. And for the associativity, you take A comma B, C comma D, and E comma F, and you have to take the compositions. Okay, you have to know that if here is A and here is C in the first position A and C, so here in the first component this is A minus C, and if it is second in the second position B and D, so here in the second position B minus D. Okay, so you have to check the both associativity and commutativity by your own. Let's do one good question and we'll just close the session. Okay, uh, given question is given that this composition is uh, associative binary composition. Okay, associative binary composition, it is already given to you that this is associative binary composition on the set S, and we are defining TBA subset, and we're defining TBA subset of S, TBA subset of S defined by, how we can define T we can define as those element of S, such that those element A compose X and X compose A for all X in S. Don't worry, I will tell you that what does it means. So now question is, prove that T is closed. Prove that T is closed under, जो देखने में जो भयंकर हो रहा है वो उतना ही आसान है. ओके, Acha, first, let me tell you now what does it mean. It is closed under composition. It means you have to prove that this composition is a binary composition under the set T. Whenever you are encounter with the term closed under this operation, so it means you have to check the binary composition. Okay, that means for all a comma b pair, okay, that's image is in T or not, or is in the set or not, for all a b. Okay, fine. Now what does it mean? It means those element of S, इसके वो elements जो बाकी हर एलिमेंट के साथ कम्यूट करे. So let me give an example. I am not giving the example, I am just giving you the explanation. Okay, A, B, C, D. Okay, let's suppose we're assuming two elements B and D. Okay, we're assuming two elements B and D, and by some calculations we know that these B and D commutes with every elements of the set A. It means if you do B compose A, so it will give you A compose B. If you do B, now B compose B is equal to B compose B. Okay. Now B compose C is equal to C compose B, and B compose D is equal to D compose B. Okay. Similar way में D compose A is equal to A compose D. D compose B is equal to B compose D. D compose C is equal to C compose D, and self element is always commutative, so decompose D equals to decompose D. It means these two elements belongs to B and D belongs to D. This set exactly says this. Okay, so you have to read the sets very carefully. Okay, this is the one more thing. Okay, in the B.Sc, if you can't read the set, okay, so you can solve any problem. That's the thing. Okay, so what does it mean? That those elements are in T, which commutes every elements with S. Okay, so it means this. Okay, let me erase these things. ये पीपीटी का जो इरेजर होता है इतना छोटा होता है ना भाई, दिक्कत ही दिक्कत. इसमें तो 1 मिनट चला जाता है इसको इरेज करने में. Okay, so answer. So what you have to do? So you have to take two elements of T. Okay, let A comma B belongs to T. Okay, so you have to check that A compose B is in T or not. You have to just check A compose B is in T or not, because before, let me give you, like when you learned about the compositions, what we actually did, that we just check for all AB in A cross A, we have to check A compose B belongs to A. Okay, for all AB in A cross A, you have to check A compose B belongs to A. Okay, fine. So you have to just take two elements. Where it is? Okay, A compose B belongs to T. Okay, so A comma B pair will be in T cross T. So you have to just check A compose B. Okay, before A compose B, since A is in T, then we can say that A compose X and X compose A will be same for all X in S, because that's the definition of T. Those elements are in T which commutes with every other element of S. Okay, since B belongs to T, so B compose X is equal to X compose B for all X in S. What you have to check? A compose B. Okay, you have to check A compose B. Okay, so if you check A compose B belongs to T or not, so what you have to prove? You have to prove for A compose B belongs to T, you have to prove that A compose B of X is equal to X of A compose B. You have to prove this, then you can conclude that A compose B belongs to T, because those elements are in T which satisfies these conditions. Like A is in T because A commutes with every other element. So A compose B will in T if you can show that A compose B of X and X compose A compose B will be same for all X in S. You have to prove this. So to prove this, so let's start with A compose B compose X. Now you know that T is a subset of S. So whatever element is in T, that element is also in S. And we know that this composition is a associative on S. So we can write it as A compose B compose X. Okay. So now A compose, what is B compose X? B compose X is your X compose B. B compose X is your X compose B. So again we just perform the associativity. Okay. And whatever your A compose X is your X compose A. Okay. Compose B. Okay. So what we just got. Okay. What we have just got. Yeah, we got the thing. Now since it is associative, so we can write X compose A compose B, and we are done, baby. We're done. So A compose B compose of X is equal to X compose A compose B. And since this X is not just a particular X, this is for all X in S, for all X in S. If you not write this for all X in X, so your marks will be deducted. Remember that. Okay. This notation is very important. So it means T is closed under this composition. That's very easy thing. Okay. So fine. So you have to just rate the set first of all. If you understand that what does it mean, so you just calculate it. And the second thing is important here, that you have to prove that T is closed. It means you have to prove that A compose B, the portion that you take from the T cos T sections. So A compose B will in T also. So now in which condition A compose B is in T? If you can prove that A compose B compose X and X compose A compose B for all X in S is equal. So you directly say that A compose B is in T because that's the condition of T. So we just start with A compose B of X, and we know one thing, that composition is associative on binary composition on S, and since T is a subset of S, and then you can say that every element of T is in S. So you can say that A compose B compose X is equal to A compose B compose X. Okay, we just some a little bit of arrangement, and we just apply the associative property and just doing these things, and we just got A compose B of X is equal to X compose A compose B. That's very easy thing, and you can just really conclude that is a closed under compositions. So that's it. That's the beautiful questions. I think you should once check after this session. Okay. So this is binary composition is khatam, and binary composition is, I mean, there is nothing to teach about. There's nothing to learn about, binary composition. So it's very basic thing. So from tomorrow's class we'll start the very new thing to you. So you already learned these type of things in your class 12. So from the next class we'll say teach something. I mean, I will teach something, the very new thing, that is group wide. Okay. So that's it for today. मिलते हैं next class में. तब तक के लिए bye bye. पढ़ाई करते रहिए. All the very best.